Hey, fifth grade. Our screencast today is on multiplying whole numbers by decimals. This is part 2, so we've already practiced these strategies. It's just a little refresher, a little review to get our minds warmed up and to get that extra fluency practice in before we start working in teams and independently on some practice problems. So our objective is I can multiply decimals by multi-digit whole numbers through conversion to a whole number problem. So today we're going to kind of ignore the decimals or turn the problem into a problem that's only whole numbers, and then we'll sneak the decimal back in at the end. And we'll reason about where the placement of that decimal point should be. We're going to start out with a little review of what we've been working on, which is using the standard algorithm when we have whole numbers and decimals. We have Mr. M. He wants to build a rectangular patio using concrete tiles that are 12 square inches. The patio will measure 13.5 feet by 43 feet. What is the area of the patio, and how many concrete tiles will he need to complete the patio? Well, I already see some numbers that we should be circling because of our cube strategy area. That tells me we're going to multiply how many concrete tiles will he need. And what is the area? So this is kind of a two-step. So we have 135 tenths. You can see my 135 came from this number here. I'm multiplying the length times the width for the area to find the area of his rectangular patio. But the reason why I made it into 135 tenths is because that makes it into a whole number. Right? I'm thinking I have 135 of those tens rods that look like this, but I'm not going to draw out all of them into 43 groups. So we're going to multiply that by 43 groups here using the standard algorithm. 5 times 3 is 15, write the 5, carry the 1. 3 times 3 is 9, plus 1 is 10, write the 0, carry the 1, and 3 times 1 is 3, plus 1 is 4. Now we are in the tens place. We're multiplying by this 4, which is really like 40. So we're doing 4 times 5 is 20, write the 0, carry the 2 above that 3. 4 times 3 is 12, plus 2 is 14, write the 4, carry the 1, and 4 times 1 is 4, plus 1 is 5. When we add all of that up together, if you want to use your highlighting strategy like we've been practicing, you are absolutely welcome to, so you can keep those place value columns nice and organized. When we add that all up together, we do get 5,805 tenths. So if I need to put that back into a whole number now, that's 580 and 5 tenths. That's how we would write that as a decimal. If I took these and traded them back in for whole numbers, I'd have 580 of those big tiles, and then I'd have 5 of these tens rods. Okay, so the patio's area is 580.5 feet squared. So Mr. M will need to buy 580 or 581 tiles. Think about it. 581 tiles, because each tile is 1 square foot. If he bought 580 tiles, he would be 0.5 of 1 foot short. So he needs to buy a little tiny bit extra. All right, and going into our skill that we've been practicing, multiplying decimals by whole numbers, today I gave you a decimal that is 2 places after the decimal point. So it's a whole number, some hundredths, times a bigger whole number. 7 and 38 hundredths times 41. And remember, our first step has been to use estimation. So I put 7 and 38 hundredths is closer to 7 than it is to 8. So I put 7, that's where I rounded to, times 41, I made into 40. So now I have 7 times 40, that's my estimation. So I can see later on if our answer was reasonable or not. 7 times 4 is 28, and there's 1 0 there. So my estimation is 280. That's around where our answer should be. Okay, since we are in the hundredths now, instead of the tenths, yesterday we were only working with tenths. So since we're in the hundredths now, I'm going to trade out my whole decimal for all hundredths pieces. So using expanded form, we have 700 of those little hundredths pieces, plus 30 of those little hundredths pieces, plus 8 of those little hundredths pieces. So you can see how I decomposed that decimal up here. Then I'm keeping my 41 as 40 plus 1. Okay, our whole number is pretty easy to break up. So we're going to start using our area model. That top row is pretty straightforward, 738. Can you see that 738 over here in our standard algorithm? 8 times 1 is 8, 3 times 1 is 3, 7 times 1 is 7, and putting a 0 because now I'm in the tens place. So you can see the first row here matches the first row here. Now to finish off our area model, we have 7 times 4 is 28, and there are 1, 2, 3 zeros there, and 12, 2 zeros, 1 0. All right, so when we add these numbers up, we should get a number here that kind of reflects this row. So 4 times 8 is 32, carry the 3. 3 times 4 is 12, plus 3 is 15, carry the 1. 7 times 4 is 28, plus 1 is 29. So 29,520. There's 28,000, plus 1,000 is 29. 29,000 plus 200 plus 300 is 29,500 plus 20. Use some mental math strategies there. So we see the second row reflected here in our standard algorithm, just like when we had 3-digit by 3-digit multiplication, just like when we had 3-digit by 2-digit multiplication, our area models always connect back to our standard algorithm. So they're really good strategies to kind of use together to check your thinking. And now we're adding. My numbers are a little wonky here, so I'm going to use my strategy for keeping them organized. And we're adding. We would add here. On our area model, we get 30,258 hundredths. That means those little tiny square pieces, we have 30,258 of those. So if we wanted to get that back into our whole numbers, we wanted to trade out all those little hundredths pieces for some whole number blocks. When we use this strategy with tenths, we move the decimal in one place. When we use it with hundredths, we're going to move the decimal in 2 places. So we're going to go to the very end and swoop 1, 2. That's where a decimal goes. So our new number is 302 and 58 hundredths. So once I trade out a bunch of those little tiny squares for the big blocks, I have 302 whole numbers and 58 hundredths left over. Now, this is our actual product compared to our estimation. That's pretty close. That's only about 20 whole numbers away from each other. So I would say our estimation was pretty accurate. So before you get to work on this kind of problem here with your team, I want you to try these 2 problems on a whiteboard with someone next to you, so that we can apply this strategy here right away. You can choose area model, you can choose standard algorithm. Please use estimation either way so that you can make sure your answer is reasonable. Also, what we have to pay attention to because of this objective is thinking about where that decimal point goes. At the very end of the problem, where do I put that decimal point? Where do I put that decimal point so that this problem makes sense? Using your estimation will help you to figure out where you need to put that decimal point. If I didn't remember this strategy down here and connect it back to our lesson on tenths, I would have had 30,258 as my answer, and I know that's not correct. But if I use my estimation strategy, oh, this has to be around 280. Okay, well, if I put my decimal here, that's 3 point something, that's not right. If I put my decimal here, that's 30 point something, that's not right. if I put my decimal here, 302, that's pretty close. If I put it here, 3,025, no, that's not right. So I can use the estimation strategy to help me pinpoint where my decimal point should go. Thanks so much.